One of the most important concepts in physics is vectors. Vectors appear throughout physics courses, from graduate courses in nuclear physics and electromagnetism all the way down to high school physics. Over 70% of physics problems in an introductory physics course will require you to use vectors. We will cover vectors in detail in a later module. In this module, we will review trigonometry, which is the mathematics we will need to handle vectors. It is assumed that you are either taking or have completed a course in pre-calculus or trigonometry. So this module is just a review of the most important concepts in trigonometry that we need to solve physics problems. If you master the skills that we cover, they will serve you throughout your future career. We begin our review of trigonometry by looking at a right triangle. A right triangle is a triangle that has a largest angle of 90 degrees. Across from that right angle is the longest side, which is called the hypotenuse. In our particular triangle, the hypotenuse is defined by the letter C. You're also given at least one of the other two angles in the problem, usually in physics problems. In this case, I've given you the angle theta. Across from the angle theta is a side called the opposite side, and I give this the letter B. There is also a side that's adjacent to the angle. This is a side that, combined with the hypotenuse, forms the angle theta. In my drawing, that side is A. Now, there are three trig functions we will need. The cosine, which is defined as the adjacent side divided by the hypotenuse. The sine function, which is defined as the opposite side over the hypotenuse. And the tangent function, which is the opposite side over the adjacent side. Stop the video now and see if you can actually use the sides to find the cosine, the sine, and the tangent. And then I will continue and show you how it's done. We're now going to find the cosine. The adjacent side is A, and we divide that by the hypotenuse, which is C. For the sine, we look for the opposite side, which is B, and we divide that by the hypotenuse, which is C. And for the tangent, the opposite side is B, divided by the adjacent side is A. This gives us our three functions. In physics, we're not usually interested in finding the cosine, the sine, or the tangent angle. We're interested in using these trig functions to help us find sides of the triangle, that is, to break vectors into components. So in physics, usually you're given a hypotenuse, that is the magnitude of something, for instance the velocity of a car, and you're given an angle, and you need to then use that to find the sides of your triangle. The adjacent side starts with the letter A. The trig function from our definitions before that helps us find the adjacent side is the cosine. An easy way to remember this is adjacent side starts with A. Trig function closest to A is cosine, which starts with C. If you're looking for the opposite side of the triangle, opposite starts with O. The trig function that's used to do this is the letter closest to O, which is sine, that is S. So if you can remember, looking for adjacent side, use the cosine. Looking for the opposite side, use the sine function. We'll rearrange our definitions now and write this down in your notes. Rearranging our cosine function, we find that adjacent side is hypotenuse times the cosine function. Notice the units for the side will be contained in the hypotenuse. And rearranging the sine, we get opposite side is the hypotenuse and times the sine function. Again, any units that may exist in the problem will be contained in the hypotenuse. In some physics problems at the very end, we'll have the two sides and need to find the hypotenuse. The Pythagorean theorem does this. One side squared plus second side squared is hypotenuse squared.